All right, so continuing. If we're going to simplify this fraction, we're going to need to factor the top and the bottom, the numerator and the denominator. So this is the fraction that we're starting with. All right, so to factor that, the numerator, this one on the top, it actually is a special case because we have a perfect square here, perfect square there. And if you multiply their square roots, you get 1x, which is half of the middle. Okay, so it actually is a special case. All right, so the square root of this one is x. The square root of that one is 1. If you multiply those two together, you get the 1x, which is half of the 2x that we have up above. So when writing the factor, you'll have the x times x for the first, and the 1 times 1 in the last. This goes with the biggest number, but they're the same. This tells you they're the same signs, so we know they're both positive. All right, in the denominator, we've got a perfect square and a perfect square there. So let's see if we can do a different special, or another special case on that one. The square root of this one is 2x. The square root of 1 is 1. When you multiply those, you only get a 2x, which is not half of the 3. But this would have not worked anyway, because for this to work, this always has to be a plus. That has to be a plus to create the same signs. All right, because on this special case, we can also write it like this. So when you have a trinomial, 3 terms, where the first and the last are perfect squares, and all this works out, okay, everything works out, you can use this. This has to be a plus, because this, if it's a special case, it will produce the exact same thing, but you can write that way. Okay, so this denominator, it's not a special case. It doesn't follow those rules, and it doesn't have a plus at the end. So we have to actually factor this out. So I'm going to factor out the 4x squared plus 3x minus 1. In order to factor that out, I'm going to use the factor by grouping method. So that is where we take the first term and the last term, just the numbers, and we multiply those together. So 4 times 1 equals 4. Then we write the factors for that, 1 and 4 and 2 and 2. Then we ask ourselves, do either of these subtract to give us the middle? So subtract to give us the middle, and that would be the 1 and the 4. So the 4x squared out front and the minus 1 out back, we're going to keep those. And once we've found which factors we're going to be using here, we're actually going to rewrite this 3x using a 1x and a 4x. Now, some of the things we've talked about earlier, they still work. For instance, this still goes with the bigger number, so it's going to go with that 4. And this tells you the signs are different. So if that's a plus, then that one over there needs to be a minus. And if you look at this, when you put these together, you do still have 3x. So from here, when we're doing our factor by grouping, we're going to look at the first 2 terms and the last 2 terms. So the first 2 terms have an x in common. If you factor those out, it leaves you 4x minus 1. Notice that the sign in the middle right here is a plus. So we're just going to factor something out that's a positive. But when you look at these two, nothing can be divided except for 1. And when we're doing this method, we do factor out the 1, which leaves us a 4x minus 1. Okay, so when we look at, I'm going to call that a term, and I'm going to call this a term. We'll look at those 2 terms. we see that they both have a 4x minus 1 in common. When you factor out the 4x minus 1 from both terms, they're gone, and that leaves you an x plus 1. So that goes on the denominator. So I'm going to go back up here and write that out. Now, before I complete part A, I'm going to go down here to part B, because part B is wanting to know when is the expression undefined. And undefined, if you grab a calculator and you take 0 divided by 5, you're going to get 0. But if you take 5 divided by 0, it's going to have an error. Okay? It's going to be an error. So that means it's undefined. So undefined is when you have a number on top. Doesn't matter what is on top, but the bottom is 0. That means it's undefined. So when we look back at the denominator, it's really asking when would the denominator equal 0? Well, we're taking two numbers and multiplying them. When you multiply two numbers, if one of them is 0, your answer will be 0. So to answer part B, we're going to take our 4x minus 1, and we're going to set it equal to 0. And we're going to take the x plus 1 and set it equal to 0. And on the first one, over here, when you add 1 to both sides and then divide by 4 on both sides, you get 1/4. So that's one of your answers. On the other one, when you subtract 1 on both sides, you get a -1. So that's the other answer. So those two numbers, if you took 1/4 and you plugged it back in for all of your x's, you plugged in 1/4 for all of your x's, you would get a 0 on the bottom. If you plugged in the -1 in for your x's, you would get a 0 on the bottom. Okay, so now let's go back up to part A and complete it. All right, just want to show you that before we cancel, because you always check for undefined. Okay, when the bottom is 0, you always check before you cancel things out. All right, so the only way you can cancel things out is if the top factor is identical to the bottom. So you cannot go in and cancel out parts. You can't just cancel out an x. All right, it doesn't work. The entire factor has to be the same in order for you to cancel out top and bottom. So in this case, we can actually cancel out an x plus 1 on top and an x plus 1 on bottom. I could have canceled out this one instead. It doesn't matter. When you're finished, you have an x plus 1 on top and a 4x minus 1 on the bottom, so this would be your answer. All right, on this one, we're going to talk about something different. One thing we need to focus on is anytime you write expressions, the variables, you always put them in alphabetical order, and the last thing you'll write, okay, so when you write out expressions, you want them to be alphabetical. Okay, and the constant, the number, is always last. Because it doesn't have any letters, okay? So alphabetical and the constant is always last. So the first thing I'm going to do here is I'm going to rewrite this problem. So on the top, I have a 7y minus 3x. It's not alphabetical. So the 3x has the negative. I'm going to put that first. 7y is positive. This one is fine. This one, we've got the largest variables down to the smallest variables, or degrees, exponents. That was a 3, by the way. And then this one is alphabetical, so that's good. So if you were looking at these two thinking they were the same, now you see that they're not, okay? This is a negative, that's a positive, this is a positive, that's a negative. All right, so now we can go ahead and we can factor some things out. Now, what I'm looking at, though, is these two right here. They might end up being the same if we didn't have, like, both of their signs are opposite. So another thing that we like to do, we want them to be alphabetical. the constant, the number is last, and we do not have a lead coefficient of negative. So our lead coefficient should always be positive. So when you're looking at this one right here, this lead term, its coefficient, its number out front is a negative, and we don't want that. So to get away from that, we can factor out a -1. So we're going to factor out a -1 from here. So we're really dividing each term by -1, and when you do that, it changes the signs. So the 3x becomes a positive, and the 7y becomes a negative. And that's part of the factoring. We just don't like to have the lead coefficient negative. On the bottom, we can actually factor out an x squared right there, which leaves us a 5x plus 1. Because if you divide an x squared out of here, you're pulling 2 of the x's out. Divide an x squared there, leaves you nothing, so there's a 1 there. And then I'm writing down the 3x minus 7y again. So now, like I told you before, you can only cancel things out that are exactly the same, like they have the same basic factor. So right here we have a 3x minus 7y, and we have the exact same thing there, so those will cancel. You're actually dividing the top and bottom by 3x minus 7y, which leaves you a 1. That's all we can cancel because the 5x minus 1 is different from that. We don't have any individual x's as factors on the top. Okay, you cannot cancel like these. You cannot cancel those. So to write this, your answer would have, you're going to have your 5x minus 1 on top. You're going to have an x squared and a 5x plus 1 on the bottom. And usually this negative, we usually just put out front. So that ends up being that answer. All right, so now let's, we'll just continue here. Actually, I think I'm going to pause this and then we'll have another session of it here in just a second.